My name is Felipe Hoffa. You know that I work at Google. You don't know maybe that I live in San Francisco. I was born in Chile. And my job is to be a developer advocate, to work with Google technologies that you can use too. I work with Google Cloud. And hopefully you will get some interesting facts, details, and tools, things that you can use from this talk. Just quick show of hands, who here works with big data? Yes, excellent. That's my people. Who here knows BigQuery? I see some illuminated people. You know how good it can be? I'm going to show you a little bit of BigQuery here. Open data tools, you can open data datasets that you can use to mix with your own data, and the mix of both is great. So just to start with a little inspiration, why are we talking about big data now? Why didn't we have big data 20 years ago? What are the three steps that brought us here? First, price. Price is super important. There was the same amount of data a year ago, 20 years ago, 30 years ago than now, but 10 years ago, we had to delete it. This was the best technology we could get to store 10 megabytes. So instead of storing, we had to delete. Today, it's better to store than to just delete. Access to data. This is Tim Berners-Lee, the guy that invented the web, 20 years later asking for us to share data, share raw data now. People are doing it. We have open data portals all around the world, open data sets, and it's good. Israel, I think it's in the number 40 position in how open your data sets are. And speed is super important. Not only to download data, if you have big data sets, spending hours downloading them is a lot. You've been there. Also, interacting with data. You want to have conversations. You don't want to write letters to data and wait for answers one day afterwards or 1 hour afterwards. So what are we doing at Google about this? Well, we developed a lot of the basic technologies that power what we're doing now. Hadoop started from the MapReduce paper. HBase started from Bigtable. Dremel is a paper that started BigQuery, that is now an open service. And we have a lot more services. I could speak for a long while about Dataflow, our new evolution of MapReduce. I could speak of Bigtable that we just launched as an HBase replacement. That was last week. But today I'm going to focus on Dremel and BigQuery, the product. It has many characteristics. It's easy to use, no indexes, no vacuuming, no waiting for nothing. You just put your data there, it works. It works fast with SQL. And you all have a free monthly quota, so anything I'm doing here with open data, you can do it yourself. While I'm doing it at home, it doesn't matter. It's open and ready for usage. I have lots of videos, but instead of talking about them, I want to feature some of the Israel startups I've been working with. This is from Kula Data. Anyone here went to their presentation earlier? Yeah, they're doing amazing analytics, behavioral analytics. They're extending SQL, and at the core of their systems, I got their permission to say this, they have BigQuery as their tool. This from Rounds, instant group video chat. I also talked to them before here. This is their Elasticsearch Kibana dashboard, but for big data, when they want to analyze all their data, they are using BigQuery, and they created a BigQuery streaming tool, so they are streaming all their records to BigQuery in real time, and they wrote it in Go, it's open source, it's awesome. There are many more uses in many sectors, and today I will focus on some of them. So let's talk a little bit about price. This is the price of storing data in BigQuery throughout the last 2 years. It goes down, it's 85% down from a year ago, and it continues to go down. This means you can store all the data you need to store. The current price is $20 per terabyte per month. So if you need to store data, just store it there. And there is no other cost until you run queries. You just pay per query. You don't have to worry about nodes, hours, none of that. Speed. How many page views Wikipedia has in a month? Just to show you how fast this can be. Any guess? Give me a number.
2 million.
5
billion.
billion. 5 billion, I like that number. Let me show you what I have here. I have BigQuery. BigQuery works with a REST API, but I also have a web UI to make these things more interactive when you need them. Let's say September 2014, October, November, let's do November, or any month you want. I have this table shared, 5 columns, that basically say this page, this title, had this many requests at this hour. So it's not raw logs, they are aggregated per hour, per page, per language. And in this table, that happens to be 370 gigabytes, I have 5 billion rows. So it's more than 5 billion. We can write a simple SQL query that sums the request. And it ran in 1.5 seconds, is 44 billion page views in November last year. And just remember that I have to record this talk, so I will start recording it now. Sorry for the first 5 minutes, but you will get the rest and I can give you the slides. Click to record the full screen. Yes, I'm recording now.
Wikipedia data?
Hmm?
Is it real Wikipedia data?
Yes, it's real Wikipedia data.
So how do you have an access to that?
I will show you how I have access to that. I will answer your question. So it's 44 billion page views. This was fast. I added 5 billion rows, but it's not that easy it's easy if I already have the result. So let's run some regular expressions. The title, where the title matches something. Any random word?
Israel.
Israel, okay. Something that starts with is and has an L afterwards. So let's run the query and see how many page views we had in November last year. How long does this take to run? 5 seconds. 5 million page views. You might want to know what's the title of these pages. So we group by title, the second column. We order by the first column in descending order, and let's get the top 10 results. Top 10 results, how long does it take to go through 5 billion rows? Is it fast? 6 seconds? Yes, the top one was Israel, filed by the Palestinian conflict, different process. Yes, it wasn't much of a regular expression, but it works. As you can see, it's fast. We are going to see more of Israel's story now. How does this work? What's the magic behind this? First, we don't need to store data with locality. We just store it in distributed storage. We have lots of storage at Google. So we just put everything there in columnar format. And when we have a query like this, we read only the columns that are important to the query. We read that with many computers at the same time, as many computers as we need to make this fast. And these computers start reading the columns and filtering everything that is not important for the query. Then we group the data, then we have more servers that continue grouping until we have a last root node that emits all the results in 7 seconds, or approximately that. How did I get the Wikipedia page views? I want to answer that too. How do I load them into BigQuery? I just go to Google and look for, not BigQuery, Wikipedia page views. See, it was easy. I come to this site that is offering the raw data for 2015, May. Let's jump to May 10 a.m. UTC, so that's now, like 2 hours ago, if we sum 3. It's pretty live data. And if I'm able, I will download it to my server. Let me connect it first. I'll come back to this. So this is the command how I load data to BigQuery. I just tell it, ingest this file, a file that I just downloaded from the internet. In this case, it's a CSV that's compressed, so it's pretty easy to read. I tell it, put it on this table, and then this CSV happens to have 5 columns, where 2 are integers. This is a special CSV, doesn't have it uses space instead of commas, and it doesn't have quotes. Can I duplicate now? Yes. I really want to work with live data that no one has seen yet. This is 1 p.m. Israel, the log from there. I did it earlier with earlier data, but let me change to what's happening now. I basically tell it that it's, instead of being 5 a.m., it's 10 a.m. and it's 10 a.m. And then I can copy and paste it here as soon as this gets done. I'll be back with them. Let's continue because we don't have much time. Let's talk about open data and BigQuery. BigQuery, you can have your private data. That's what Hula Data, that's what Rounds has. But if you want to share data, it's super easy. That's nice when you are working with third parties where you want to share their data, and instead of giving them a file or access to your own systems, you can just share data with an email, with a group, with a corporation, etc. Some open data you can find here, genomics. You can find the complete genomes of thousands of people. I did a talk last week at Strata how to do that, so today we'll skip part of it, but turns out that genes are a lot of character strings, and we need tools to understand them. And it turns out we can put these genes, these strings, on SQL tables, relational tables. They are pretty big. And you can run queries. You can try to understand cancer. You can try to understand autism. There are people doing that right now. With this query, simple SQL query, I'm looking at the number of variants that each of these 1,000 people have. Some people have more allele variants. Sorry, I'm not strong in explaining genomics. But if I chart that, I get clusters of people. What explains these clusters? Just looking at the genomes, the difference in each code. Basically, it's ethnicity. I'm coloring this with ethnicity, and I can see that each gene falls in a rather clear pool. So if you sequenced your genome and ran the same query, you would see where you could fall in this cluster. Let's jump to a different place. Before doing that, let me show you how to finish this. Yeah, I downloaded the GC from the internet. I want to run my load command. I'm leaving everything on BigQuery, and we will come back to this. Let's talk about news. There's Caleb Litaru in Washington. He's collecting all the news pieces he can find around the world. He's looking at the news, the blogs, he's looking at websites, he's looking at TV if he can. He's translating everything, so it's not an English-centric data set. And he's leaving everything on BigQuery, so you can come and see more than 300 million events from the last 30 years. If you wanted to see a timeline of the news events for Israel, I ran this query last night. This is the amount of events he has recorded for the last 30 years for this country. Now, this, as you can see, the amount of events is growing through the years. What happened here is not history, but the web. We have more information now. But I can normalize this data. I can divide by the number of events we have this year, and I can get a clear timeline of what is happening in Israel, what has happened, when has Israel captured the world attention. I got September 82, and I got January 2009. You know more about the history of Israel than me, so I won't try to explain this. But I can show you the timeline for my country. That's Chile. Any guess on what the top three events are?
Earthquakes.
Earthquakes, good one. Yes.
Mining accident.
Which one?
Mining accident.
Yes. So I'm marked here. We have here Mr. Pinochet when we had the election to not have him anymore. Here is the earthquake of 2010 and the Chilean miners. Good call. And yes, you can see the timeline, you can see story, you can see what's happening around the world and what has been important for any country and slice it however you want. Let's talk, for example, about weather. Weather data, it's super interesting. It's especially interesting if I have my own data and I want to mix it. For example, I know how much I sold in each store last month. I know how much I sold every day. I know how users were using my application. But do I know when was it raining? Is it rain or the heat have any correlation with what I'm doing? I can do it here. I have took data from the NOAA, put it on BigQuery, and just wrote a query of how was the weather in Tel Aviv, Ben Gurion, last year. And now I know exactly when it rained, what was the minimum temperature, what was the maximum temperature. I can join this data with my own. Freebase. Freebase is, here someone knows Freebase? Yes, we have some Freebase users. Freebase is Wikipedia, basically a knowledge database. A knowledge database made an RDF graph that I have loaded into BigQuery, and once we have it into BigQuery, I can start querying it. For example, this is the average age, so a chart of the ages of the people in Wikipedia. So you can see that the most famous people are around 26 years old, and there is this, probably these are the baby boomers. So with my friend Eva, for a different talk, we wanted to know how many women we had in Wikipedia compared to the number of men. Where were they born, if there were regional differences, age difference, profession differences. And to end that talk, we developed this query that tells me who are the most famous women on Wikipedia. How can you tell who's the most famous one? On one hand, we have all the women on Freebase, but to see popularity, we would need to look at page views, and we happen to have the page views. So just let me copy that query. I can put it here, and since I just loaded new data, we can see who are the most famous for this last hour. So 2015, 05, yeah, we just loaded this dataset. I have no idea what the results are, but I'm doing a join of the Freebase objects with, okay, I want to explain the query because we are already done. The most famous, most page views right now, it's in USA for Scarlett Johansson, followed by Margaret Thatcher right now. I have no idea. We had different results earlier, just to show you what happened earlier during the day. 05. We did this, yes, it was still Scarlett Johansson, but the second one was Anne Pauling. What is happening with Margaret, I don't know, but let's go back to her. Margaret, I'm curious. What is happening here? I don't know why she's in the news. Securing Nighthawk for Peter Morrison despite, okay. That's, and so, sorry, I didn't know. I can download this data as CSV, just because I like looking at the full data I got, showing Finder, open with text edit. And now I have a nice CSV of what just happened in this last hour. I can go to a map that my friend Eva wrote. When you have geodata, put a map on it. I can paste the data here, and here we have a map of everyone around the world and who got the most pages this last hour. Impressive. And just to finish, because time is short, 3 big steps. One is Price, whenever it loads. Price is important. We are working with that. Speed is important. We just saw how fast we can do things with BigQuery. Try it for yourself. And access. Access is a lot about sharing data, getting our governments to share data. So please do so. I love feedback, so if you have feedback for me, if you like the talk, please rate it here. If you don't like it, please tell me why. Thank you very much.